Hello, good day. Welcome to our first online class, and in this video, I'm going to discuss basic principles and practices in clinical chemistry section. For this topic, the following will be our learning outcomes. Number one, explain the basic principles of clinical chemistry, solve laboratory problems by applying the correct formula and derive formula from the mother formula. And of course, to identify pre-analytic variables that can adversely affect the laboratory results. Okay, so for the overview, this will be the coverage of this topic. Units of measure, reagents, chemicals, and reference materials rather, clinical laboratory supplies, laboratory mathematics, and specimen considerations. One of the best things that you need to remember in clinical chemistry is what we call the units of measure. Most of the times na nagwo-work na kayo in the clinical chemistry laboratory, you will deal on the measurement. You will deal in analysis of body fluids. Most of the times, yung mga body fluids na i-measure nyo in this section is serum. Okay? And one of the most important things to remember is the units of measure. What is the application of units of measure in the clinical chemistry laboratory? When we said units of measure, it defines the physical quantity or dimension, such as mass, length, time, and volume. We have what we call the conversional or traditional units, and we have what we call the international units. I guess you are aware of what we call Sistema Internazionale de Unites, or commonly known as the international units. This unit is used by most of the scientific literatures and in clinical laboratories. Assuming that you are working in the clinical laboratory already, you will notice in the results in the result form of clinical laboratory science or clinical chemistry, there are two columns. One is for the conventional unit, and the other one is the Sistema International unit, or the standard units, or the international units. What is the purpose of this one? They prefer SI for laboratories, for reference range, for the unit that will help us to identify the dimension of the volume present in the analyte of our sample. Remember guys that this is useful for us to take note the volume, the mass, or the quantity of the analyte present in our sample. Remember, this time, your sample is not chemical. The test that you are going to use, that you are going to perform in this section is not anymore commercially prepared chemicals, but instead, you will use our serum, your serum, as the specimen. Using these international units, we'll be able to know, let's say, the amount of the analyte, the quantity of the analyte. For example, creatinine. Okay? What is the concentration of creatinine in your blood, present in your blood? Say, in traditional unit or conventional unit, we use milligram per deciliter. But in international units, we use millimole per liter. Somehow different from one another, but actually they have the same quantity. It just so happened that you change or you convert the conventional unit into international unit which is the most commonly used or which is the acceptable or preferred units in clinical laboratory. We also have what we call SI conversions. I am sure that you are all aware of what is SI conversions because this is not the first time that you heard it, right? I am very sure that you are very used to SI conversions because when you were in your general chemistry or in organic chemistry, your instructor taught you of how to convert from one unit to another unit. International SI conversions is still applicable. It is still important in our clinical chemistry laboratory. However, there are quite difference or somehow difference in terms of the conversions. Because before, you are used to convert meters to kilometers, Kelvin to Celsius, Celsius to Kelvin, and vice versa. This time, you will convert your conventional units to international units following the conversion factor of the analytes, no? Of the analytes that can be seen or tested from our body. Let's say, for example, creatinine. Creatinine, okay, the conventional unit is milligrams per deciliter. You will be asked to convert it into SI unit, which is millimole per liter. Something like that. So medyo ile-level up po natin. I still remember my lecturer when I was in my review days before my board exam. My instructor, my reviewer always keep on saying, itataas natin ang level ng discussion. Basically the same thing in this class. Instead of converting meter to kilometer, inch to centimeter, we will convert the unit of each analyte that can be tested in human body. But don't worry, okay? I'm going to give you the traditional conversional factors that will help you to convert your conversional unit into system unit or international units. But before that, no, when we said conversion, SI conversion, we convert between SI, move the decimal by the difference between the exponent represented by the prefixes. I am sure that you are all aware of what are those prefixes. Kilo, deci, milli, centi, those are the prefixes that you are used to know, right? Still applicable in our class. Okay? For example, convert 1 liter to microliters. According to the definition, no, based on the definition, sabi natin, move the decimal place by the difference between the exponents represented by the prefixes. And then you were asked, convert 1 liter to microliters. Now, I want you to take note of this. I want you to remember this. Why, sir? Because this time, in clinical chemistry laboratory, you will not use the glass pipette, but rather, you are going to use the automatic pipettor, wherein you will just sip the sample and dispense it into your test tube. And in our case, most of the clinical laboratory, the available automatic pipettor is set at 1000 UL. If that's the case, okay, if that's the case, if the standard or most commonly used, most commonly available, most common, I'm sorry, the most common pipettor in the clinical chemistry is 1000 UL, then how are we going to aspirate? How are we going to dispense 1 liter of our analyte? This will count the conversion factor. Again, let's have a review. We said that we are going to move the decimal places according to the exponent or the difference of exponent. Let's try to solve this one. Okay? Convert 1 liter times 2 microliters. People, guys, remember, remember when we said microliters, okay? When we said micro, okay? When we said micro, the exponential form of micro is 10 raised to negative 6. We have liter. Wala siyang prefix, right? So assuming that my liter has no prefix, then it is 10 raised to 0. Oh, don't be confused. 10 raised to 0 is equals to 1. Remember our grade 1 algebra, no? I still remember my teacher when I was in grade 1. She taught me of algebra. Sabi niya, any number raised to 0 is equals to 1. Now, applying the principle of getting the difference between 10 raised to 0 and 10 raised to 6, then we have here 6 as our difference. Now, ang sabi sa atin, moving the decimal places by the difference of the prefix. So, if we have here your 1, no? If we have here your 1, then we have to move 6 decimal places. 1, 2, 3, 4, 5, 6. There you have it. Meaning to say, 1 liter is equals to 1,000,000 microliters. Okay? I hope you get it. 1 liter is equals to 1,000,000 microliter. Okay? I know that you are a bit confused, but remember this one because this one will help you to remember, will help you to convert, no? Sabi dito, convert the larger unit smaller to large unit. Move to the left. Ibig sabihin, you have to move your decimal places to the left. Convert to smaller unit, move to the right. In our previous example, we have 1 liter, which is larger than microliter. What we did is to remove our decimal places to the right. How many decimal places? 6. Where did we come up with the 6 decimal places? The difference between the exponent of our power of 10. Okay, please take note of this one. Have a screenshot of this one because it is important in our clinical chemistry section. I'll give you another example. Convert 5 ml to microliters. Convert 5 ml to microliters. I want you to solve this. Okay? I'm giving you 1 minute to solve for this one. 5 ml to microliters. Convert 5 ml to microliters. Okay? So how are we going to convert this one? We have 5 ml to microliters. Take note, we have here milli. And based on our exponential form, that is 10 raised to negative 3. Okay? Micro is 10 raised to negative 6. Okay, so 6 and 3. The difference is 3. Okay, don't mind of the negative sign para hindi po tayo ma-confuse. 6 minus 3 is 3. Now, are we going to move the decimal place to the right, or are we going to move the decimal place to the left? Okay, we are going to move the decimal places to the right because that 5 ml is larger than microliter. So having said that we have here 5 and we are going to move it 3 decimal places, 1, 2, 3. Then 5 ml is equivalent to 5,000 UL. Okay? 5,000 UL. Now, in our clinical chemistry laboratory, there are 100 UL and 1,000 UL automatic pipetter. Assuming that usually, remember, usually this 1,000 UL, this is our blue tips. Yan. This is our blue tips. And the 100 UL, this is the yellow tips. Why is it color coded? It is for us to identify it, to recognize it easily. Okay? So assuming that you are going to use your blue tips, your 1000 UL automatic pipetter, and you have to dispense, you have to aspirate 5,000 UL. So meaning to say, you have to dispense, you have to aspirate, and you have to dispense 5 times. Sir, bakit po 5 times? 1,000 UL ang capacity ng isang tip. So times 5 will give you 5,000 UL. In other words, if you need 5 ml of your solute, no? If you need 5 ml of your solute, and then you only have your 1,000 UL pipeter, then you need to dispense and you need to aspirate rather and dispense 1,000 UL na 5 beses. That it will give you 5,000 UL, which is equivalent to 5 ml. Now, if you will be asked between 5 ml and 5,000 UL, which is bigger, which is higher? Okay, the answer is none. I repeat, if you were asked between 5 ml and 5,000 UL, and the question is, which of the following is larger? Your answer should be equal. Okay? That is the purpose of conversion factors. No? That is the purpose of conversion. Converting the number, converting the quantity into another unit, but with the same value, with the same amount. Okay? Another example. Yan. SGPT of patient 1 yielded 120 international units, and the machine flags you to dilute your sample. Sir, what does it mean kapag sinabing flag? It means that the machine notifies you to dilute your sample. The same thing when you are answering in our learning management system. You flag the question, means you need to go back. You need to repeat. You need to do it again. So basically the same thing. When the machine flags you, it means you have to rerun the test. You have to retest the sample. Sometimes it will require you to dilute your sample if the result is too high. There are some analyzers or chemical chemistry analyzers that will flag you beyond normal limits. Most especially in cases na the value or the acid value is too high. Then as a medical technologist, hindi ka lang basta, hayaan na natin siya, may sakit naman siya. The patient was diagnosed of having an end-stage renal disease. Then it is just unacceptable to have a increased creatinine. Hindi ganon. Even though the patient is suffering from any disease, you have to repeat the test if it is necessary. Okay? And of course, you have to check it. You have to compare it with the previous result. And what does it mean? What is the purpose or what do we call in checking the value of our previous or comparing the value of our previous result and our present result? Guys, remember that is what we call delta checking. Okay? That is what we call delta checking. And when we said delta checking, again, you are comparing, no? You are comparing the previous result to the present result. And that is the purpose of what we call laboratory information system. Because it will be easy for us, no? It will be easy for us to check, to validate the result of our analysis. Unlike before, if you need to do a delta checking, then you have to review your login manual or your log. But this time, since we are in the advent of automation, we are in the advent of technology, then it will be easy for us to do delta checking. Okay, going back to our problem. Ano yung sabi? SGPT of patient 1 yielded 120 units. And the machine flags you to dilute the sample. Yan. Medyo toxic si chemistry analyzer mo. Ipa-dilute mo sa'yo. And you have to dilute your sample 1:10. So easy. 1:10. Ibig sabihin, 1 part of your solute plus 9 parts of your solvent. Okay? So you need the 1 ml of your serum and 9 ml of distilled water. How many times you need to dispense distilled water in order to arrive 1:10 dilution? So parang yung example lang natin kanina, no? Wherein we have 5 ml, convert it into microliters, that is 5,000 microliters. This time, you need 9 ml, and the available automatic pipettor is 1,000 UL. Then, the same thing. Convert 9 ml to UL, which will give you 9,000 UL. And one dispense or the capacity of each tip is 1,000 UL, then you have to repeat it 9 times. In order for you to take it, in order for you to dispense 9 ml. But I want you to remember this one, people. There are some problems na na-encountered usually of students in terms of using the automatic pipetter. Okay, don't worry. As we go along, no, I'm going to teach you on how are we going to use our automatic pipetter. Well, I think naman you were able to use that before during your biochemistry laboratory, no? But this time, now we are going to use that. We are going to use the rest of the days, the rest of our laboratory sessions for you to experience it. So that when you go to your internship, no, you are not amazed of the things that you can see in the laboratory. Don't worry, you will be able to use that. Why I'm giving this emphasis? Why I'm taking too long in conversion of ml to microliters? Because I want you to remember that. Because the rest of your days in the clinical laboratory, when you are working in clinical chemistry, you will deal on that. Lagi mo siyang tatandaan. Every time that you will enter in clinical chemistry laboratory, you must remember that 1 UL or 1 ml is equivalent to 1,000 UL. Okay? 1 ml is equivalent to 1,000 UL. Don't forget that. I will curse you if you will forget that. Maybe a simple thing, but it will be beneficial to you as you go. Most especially, since that you have your research. No, magre-research kayo dyan. Some of you will work on the quantification, quantitative analysis. So, yung mga ganung bagay. So that it will not be too hard for you. Hindi siya ganun ka-burden sa inyo if you don't know this one. Reason why I am giving you an intensive explanation and I'm giving an emphasis in this one for you to remember and for you to take note. Okay? Now reagents. I want to give, I want to make it clear. During your biochemistry class, during your analytical chemistry class, during your organic chemistry class, you are used to have your reagents available in the working bench, available in the reagent table, reagent area. And you're just going to dispense it. Ay, halimbawa, in your chemistry laboratory, in your biochemistry laboratory, which I think you are very familiar with, okay, you get your, let's say for example, 1% glucose solution. That is your analyte. That is the sample being tested, the 1% glucose. And then you drop your Benedict's solution. In order for you to take note the amount of glucose, the amount of sugar present in that solution. Ganun yung ginagawa nyo in your biochemistry class. In your analytical chemistry class, you have to compute, you have to prepare the amount needed in order for you to arrive with your desired volume, with desired value. But this time, you are going to work, no? You are going to work with your body sample, mostly serum. Okay? So we will use different reagents in clinical chemistry. Siyempre, hindi naman po pwedeng wala because our chemical or chemistry analyzers will require you your reagent. But this time, you don't need to dispense 5 ml, 2 UL, do this, do that. No. You are going to feed your sample in the machine, and the machine will be the one to read it for you, to test it for you, to do it for you. However, the end is still on your hands. Bakit? You have to check it, you have to analyze it, and you have to make it clear na yun talaga ang result. Don't rely too much on the result of your analyzer. Kasi sometimes, most of the times, nag-out of control yan. No? Out of 2S the control. If that is out of 2S the control, then you have to check your result. It might be an erroneous result. Now, what I am saying is, in clinical chemistry, you are going to use reagent, but not the typical reagent that you are used to know. Hindi na yung sulfuric acid, hindi na yung hydrochloric acid, hindi na yung sodium hydroxide, hindi na yung si ganito, hindi na si ganyan. But you are going to use agents that will help you to quantify the analyte being tested. Now, there are two types of chemistry. So, ano pong ibig sabihin nyo ng two types of chemistry? Okay? We have the wet chemistry and the dry chemistry. Okay, again, we have the wet chem and we have the dry chemistry. So, ano po yung ibig sabihin ng mga yan? Okay? When we said wet chemistry, then when we said wet chemistry, these are the analyzers, these are chemical analyzers that uses liquid reagents. Okay? That uses liquid reagents. And when we said dry chemistry, okay, if we're going to discuss dry chemistry, this chemical analyzer requires you your cartridge. Sometimes chips. This time, liquid. Ibig sabihin, liquid chemistry and liquid reagent in form of liquid. I am sure naman you are aware of that. Okay? So, meaning to say, your serum plus the liquid reagents in order to yield the analysis. In dry chemistry, there is a chip wherein the serum no will go inside the machine where you are going to feed your sample. There are tiny tubes or what we call cuvettes that will get or aspirate your sample, and these transferring cuvettes, no? These transferring cuvettes will transfer your sample, your aliquot. O siguro naman, alam po natin ang aliquot. The small sample taken from your sample, small amount of sample taken from the mother sample. Now, inside this chemical analyzer, there is a microcuvette that will transfer your serum or your sample into the chip. This chip will react, no, on your sample depending on the chip. Let's say, for example, this chip is for creatinine. Then it will produce this color. No? It will produce color. This color will be read by our analyzer. This is what we call colorimetry. Colorimetry. Okay? Colorimetric principle. Okay? Don't be too overwhelmed. Don't worry. Because we are going to discuss that as we go along to analytical procedures. Okay? So yan lang. I'm just giving you an overview of what are the reagents used in a clinical chemistry laboratory. Then, hindi na po masyadong uso yung mga samples na ginagamit nyo in the past. Okay? Next, we have chemicals. Chemicals, no, in clinical laboratory varies on their classification. The classifications of chemicals can be analytical grade or analytic reagent, which is has a less impurities. When we said impurities, mas maliit yung chances na contaminated or mas pure, no? Yung ating reagent, yung ating chemical. It can also be an ultra pure. Okay? When we said ultra pure, it can be used for chromatography, atomic absorption spectrophotometry, immunoassays, and molecular diagnostics. Remember also when we said ultra pure, these are reagents, no, these are reagents that undergone additional processing that makes them suitable for special procedures. I repeat, ultra pure are type of chemicals that undergo additional specifications. I'm sorry, additional processing, no, that makes them suitable for special procedures. And when we said special procedures, these are the following: chromatography, AAS, immunoassay, and molecular diagnostics. Okay? We also have here your chemically pure. We also have your national formulary. National formulary and United States pharmacopoeia are both suitable for drug manufacturing. This is the reason why you heard it from Sir Aldrin. This reagent is an analytical grade reagent. This reagent will be used for drug manufacturing during your analytical chemistry days. Those are the things, reagents, chemicals na ginagamit nila. We also have American Chemical Society, the purification of analytical reagent and chemicals. Again, when we said ultra pure, no, ultra pure, they undergone additional processing that makes them suitable for special procedures. Now, I want to give a definition then about analytical reagent aside from it contains a lesser impurities. No? When we said analytical reagent, ito po yung chemicals that is more specific, that meet the established specifications. Okay? Analytical reagent is chemicals that meet the specifications of ACS. Kaya yung sabi ni ACS, purification of analytical grade chemicals. Okay, so those are the types of chemicals. Sometimes it will be found, or it can be found rather, in the label of your reagent. Okay, doon, AR. Ano yung AR na yan? What does it mean? AR means analytical grade. Analytical reagent grade chemical. Lesser impurity met the qualification established by American Chemical Society. Okay? I hope at this point in time you are still with me. No? You are still watching this video. And I want you to give thumbs up in this video. I'm sorry, I thought I am having a vlog. Okay. I miss having my discussion with you, so I hope that you are still with me at this point in time. Next is we have reference materials. Okay. So in reference materials, we have the primary standard. At ano po yung ibig sabihin ng primary standard? Sa primary standard, highly purified chemical that can be measured directly to produce substance of exact known concentration and purity. This is in connection of what I am saying a while ago. During your basic chemistry classes, organic, analytical, and biochemistry, meron kang tinatawag na standard. Meron kang tinatawag na positive control. Meron kang tinatawag na negative control. Right? This time, it will be too hard for you, too hard for us to establish positive control, negative control, because the analyte that we are testing in clinical chemistry is biological samples. And when we said biological samples, yun yung galing sa'yo. Serum, plasma, urine, saliva, whatever, whatever. Those are biological samples. And it will be too hard to prepare a chemically or commercially available chemical that will give you the exact concentration, the exact component of your body fluids. Kaya yung I'm sorry, kaya yung NSIT, nag-develop sila ng certified reference materials na tinatawag nating standard reference materials that will be used for our that will be used as our reference materials. What is the purpose of this? Like what I'm saying a while ago, you have your control. We have to make sure that our machine is functioning well. Then you have to run positive control and negative control. Standards that will help us to identify if this is your correct value. Now we have your primary standards. Okay. Kapag po sinabi nating primary standards, again, highly purified chemicals. We also have what we call secondary standards. Hey, so ano pong ibig sabihin kapag po sinabi nating secondary standards? Okay. When we said secondary standards, what does it mean? Going to write it. Okay. When we said secondary standards, these are solutions, okay, these are solutions whose value are determined by repeated analysis using a reference method. Okay? Again, when we set secondary standards, these are solutions whose value are determined by repeated analysis using a reference method. Ano po yung pinagkaiba niya? No? What is the difference between your primary standard and your secondary standard? Kung sa secondary standard na-establish, na-determine using repeated analysis, si primary standard naman, purified chemicals measured to produce a solution with the exact concentration. Exact, pure, highly purified. Eksakto agad na siya yun. Si standard, secondary standard, repeated test until you determine the value to make it a standard. Kumbaga si primary, unang beses pa lang swak na siya. Secondary, you have to repeat the analysis, you have to repeat the quantification, you have to repeat it using a standard reference method. Okay? Kaya nag-arrive tayo sa tinatawag nating NSIT. Si NSIT, National Institute for Standards and Technology. Ano yung ginawa ni NSIT? Nag-develop siya ng certified reference materials na pwedeng bilhin ng mga laboratorio. Para saan? Para po i-test at para maintain ang integrity ng ating chemical analyzers. Now, we have what we call lyophilized powder. Ano po yung lyophilized powder? These are standards or reagents used in clinical chemistry laboratory for control. Powder lang siya. You have to add water, distilled water, no, to make it liquid form. That will be used as your control. Lyophilized, powderized, yung serum, lyophilized serum. As you get the lyophilized serum and reconstitute. Kapag nag-intern po kayo at sinabi sa inyo ng inyong training officer, reconstitute the lyophilized serum, no? Kapag sinabi po ng inyong clinical instructor, reconstitute, ay huwag kang iiyak doon at hindi ka naman tinatanong of what is reconstitute. Kapag sinabi sa yung reconstitute the lyophilized serum, get it from the refrigerator, gagawin mo lang doon, you have to read the label, no? You have to read the label and take note how much water you have to add. And that is what we call reconstitution of your lyophilized powder. Okay? Hindi lang basta-basta water ang gagamitin mo because we have different types of water. We have water specifications. Tap water, reagent grade water, distilled water, deionized water. Remember, tap water is not suitable for laboratory applications. Bakit? It contains ion, it contains metals, it contains elements. Kaya di ba, kapag kayo ay nag-experiment during your chemistry level or lower chemistry courses, distilled water ang ginagamit sa inyo. Bakit? Ano yung meron kay distilled water? It was purified to remove organic materials that can cause interference in our analysis. The ionized water naman, some of the ions are removed. Some or all ions are removed. The ionized from the water itself, the ionized. However, the ionized water is neither sterile nor pure. So how about your reagent grade water? Reagent grade water is classified into six. No, it is classified into six uh, classifications, specifications. And what are those? We have the type 1 reagent grade water, type 2 reagent grade water, and type 3 reagent grade water. We also have what we call special reagent water. Okay, is it here? No, I'm going to write it. We have what we call special reagent water. What does it mean? Ano po yung ibig sabihin ng special reagent water? Okay. When we said special reagent water, it means that okay, special reagent water, that is your water that no, require preparation than CLRW. Okay? CLRW. When we said CLRW, this is what we call the clinical laboratory reagent water. Clinical laboratory reagent water. Okay? Again, going back, when we said special reagent water, may require different preparation than clinical laboratory reagent water according to the intent of use. Okay? According to the intent of use. We also have what we call instrument feed water. Ano naman po itong instrument feed water? Instrument feed water used for internal measuring rinsing. Internal measuring rinsing. Ibig sabihin, this instrument feed water is the water used by your analyzer to rinse, to clean your machine. Okay? We also have your purified water, which is commercially available, din yung mga drinking water na meron tayo, and water for clinical laboratory, no? And water for clinical laboratory. And the water for clinical laboratory for clinical laboratory as follows. We have your type 1, your type 2, and type 3 reagent water. Type 1 water is used for method, no, for test methods requiring minimum interference, such as trace elements, iron, and enzyme analysis. When we said type 2 reagent water, acceptable naman to for most commonly reagents or analytical requirements. Meaning to say, I still remember in our board exam, the question is the most commonly used reagent water. Kapag ang tinanong sa'yo, The most commonly used grade of reagent water, your answer will be your type 2. Because type 2 is suitable for quality control, reagent, and standard preparation. Remember, lumabas po ito ng board exam namin. Pwede rin itanong ulit sa inyo. The question is, the acceptable or the most commonly used reagent water. And that is type 2 reagent water. Type 3 reagent water naman for autoclave water, which is also acceptable for glassware washing, not for analysis nor reagent preparation. Okay? So solution properties is also important for in clinical chemistry. Concentration such as the percent concentration, volume per volume, weight for volume, weight per weight. Molarity, no, the measure of number of moles per 1,000 for per 100 liter for per 1 liter of solution. I'm sorry, again, molarity is the measure of the number of moles or the ratio of moles per 1 liter of the solution. You have your molality as well as your normality. This concentrations, I will give a different or another video lecture for you to recall how to compute, because this topic will fall on your laboratory mathematics, which will be given in a different video. We have the colligative properties. No, colligative properties is your osmotic pressure, vapor pressure, freezing point, and your boiling point. The redox potential, the measure of the ability of the solution to accept and donate. It's just a review. Accept and donate electrons. Ang sabi dyan, Leo and Jer. Ano yung sir, mnemonic na yan? Tandaan mo guys, kapag sinabi mong Leo, hindi po ito yung zodiac sign. Kapag sinabi mong Leo, loose electrons, oxidize. Kapag daw ikaw ay nag-lose ng electrons, you are oxidized. Gain electrons, reduce. Gain electrons, reduce. Okay, I will not discuss this further because I am sure you are aware of this in your chemistry, analytical chemistry. Diniscuss na po ito sa inyo. Kaya hindi ko na siya masyadong patatagalin pa. Okay? Tandaan mo na lang. Leo, lose electrons, oxidize. Ger, gain electrons, reduced. We also have here conductivity, they measure how electricity passes through the solution. Best example, sodium chloride solution, no, conductor of heat of electricity. Then pH, the measure of concentration of hydrogen ions present in the solution. I will also give the further discussion of pH in our next video. I will give you an overview why is the pH of pure water 7. Bakit nga ba ang pH ng pure water is 7? I'll give that in the next video. Okay? As well as the clinical laboratory supplies will be discussed, no, by yourself. Sure, yeah. You just have to read it on your own, and I'm sure you will understand it naman. If you have questions about clinical laboratory supplies, then you can ask me naman. I can leave this to you. I know I can leave this to you. The clinical laboratory supplies. Okay? So thank you. I took 54 minutes. I was thinking na for 30 minutes I will be able to finish this discussion, but I miss having a lecture with you. I hope that you were able to watch it until this point. Ay pinanood nyo pa rin siya, even though it takes you 54 minutes for this short presentation. Right? If you have questions, no clarifications, please accept. I will accept that. No, I will post forum in our learning management system that you can post your insights. No? so that we can exchange knowledge. Guys, this time I am asking your cooperation because this time is the time for us to help one another to achieve our goal, which is for you to know. This time, please disregard the competition to one another. This time is the time for us to help one another to learn. But I want to make it clear, cheating still cheating is not accepted pa rin. What I am trying to say is to help one another, let us keep in touch to one another, let us collaborate in terms that all of us will be knowledgeable, not you will be dependent on your classmates. With this, I will end this first pre-recorded video and I hope you learn from this short presentation. Good day and stay safe everyone.